Awesome. So, thanks for watching the video. I appreciate it. Just helping you out with some really quick review of some pretty basic trig stuff and right triangle stuff. Hopefully this is loud enough for you guys to hear. Don't worry, it looks a lot harder than it really is. We've been looking at some of this stuff for, the past week or two, So, I already have the first little bit snipped out, so we can go over it. I'm going to go through like one of each of these. And sorry if you hear a bunch of noise in the background. I live on a very busy street. So let's go ahead and get started. So the first thing it's asking us to do is just to find the sine of 45 degrees. So I'm going to open a calculator. Now yours is going to work a little bit different than mine. So when you use your calculators, you would click the sine first. It's just a button on yours. But for whatever reason on this one, I need to I enter the thing that I want to evaluate first, and then I click the sine. So yours is just a little bit different than mine, but you guys have been, again, using it for a little while. You guys should get something that looks somewhat like this, but I don't want you to write all this. What's the point? I said round to 2 decimal places. So that's 2 decimal places, 2 after the decimal. And we see we have a 7 right there. So it's actually closer to 0.71. So that'll be my answer. 0.71. Super easy, right? So obviously you can do 2 and 3 in like 5 seconds, right? Literally a couple buttons on the calculator. These ones are a little bit more tricky. And I'll actually help you out with number 6. Because if you're looking at these decimals, you're like, whoa, Merrick. Don't know what that is, right? Well, let's look at it. So if we're trying to find the cosine of angle A, remember we're using the SOHCAHTOA, that little mnemonic device that should help us kind of figure out what our ratios should look like. So on number 6, obviously we're looking for the cosine, and we know that cosine is opposite over, I'm so silly, sorry, adjacent over hypotenuse, over our hypotenuse, right? Right, so this actually isn't too bad. Using that little formula, I know that the side length that is adjacent to angle A, right, here's my angle A right here. Right, so the side length that's actually closest, I should say the leg that is actually closest, is going to be 5.42. And the hypotenuse here is obviously C, because C is our right angle. Angle C is our right angle. And we know that the hypotenuse is whatever is opposite to that, right? We can also tell that C is the hypotenuse because it is the biggest number, right? So that's that. So, I'd probably give you credit if you made it this far. All right, that's good progress. But let's actually find the cosine of that. So I'll go to my calculator. So I'm still getting used to this one. And I'm actually going to enter those two numbers. So 5.42 divided by, I believe it was divided by 9.55. 5.42 divided by 9.55. And that actually is our cosine. So this is totally fine. You can totally use that, or you can also use this. And we'll round that to 0.57. Okay? So these are the same thing. So I kind of misspoke when I said, oh, I'll give you credit. These are the same thing. Okay? So these are both correct answers. Full credit. These are both correct answers. Okay? And then this one says, use the Pythagorean theorem to find the length of the missing side for the following exercises. So I give you a couple of cases. There's kind of two cases that occur, right? The first case is the easiest one. That's cases such as number 8 and number 11, right? And in those cases, we can just use the thing like normal, the Pythagorean theorem like normal, and it's way easier. In my opinion, you have to do less algebra. We see that C is missing, so we would simply square this number, add them together, and then take the square root. So we would use this one. All right, but I want to show you a harder one. I'll do number 9, and that's this one, right? So we see here that our leg B is actually missing. So let's write out our statement. We can actually. Oh, I kind of messed this up. I'll fix this before I print it, but I'll kind of write it out this way. I know that 9.26 squared plus b squared. We do not know what b is, so maybe I can actually color code that a little bit. We actually don't know what b is. That's what we're looking for. Equals 13 squared. That's kind of nice. C came out to a whole number. So it's actually just pretty simple. We do some algebra. I can subtract that 9.26 squared from both sides. So b squared is actually equal to 13 squared minus 9.26 squared. The only reason I add the parentheses is to make it a little bit more clear. Right, and from here I can just go to my calculator. So I'll do 13 squared. So that's what that looks like, 13 to the second power. That's 169. And then I'm actually going to subtract 9.26. And I get 83.2524. So here we can kind of see there's my 13 squared minus my 9.26 squared. So that's c squared minus, in this case, a squared. C squared, so 13 squared minus 9.26 squared, right? So I get that b squared is equal to 83.24. B squared is equal to 83.2425. All right, and then the last thing that we need to do is we actually need to take the square root of both sides, because what happens when I take the square root is it actually gets rid of that little, that squared on the left-hand side, which is what we want. So we actually just want exclusively b on the left-hand side. And when I take the square root of that number, let's see if I can actually find it. I'm not used to using this one. Well, let me do it. Where's my square root function here? Where are you, square root? Second. Where'd you go? Ugh. Where is he? There we go. Duh. Square root. There we go. So again, yours is actually a little bit different. I'll explain in a second. And I'll just stick to the 9.12. That's fine. Again, with square roots, a lot of the time, so we get 9.12. And I can actually show you this on GeoGebra. I wonder if it'll let me, sorry. I wonder if it'll let me do this. So I wonder if it'll let me make a triangle. Or I'll do a right triangle. I don't care about a grid, don't care about the axes. And I wonder if it'll let me fix these. Can it? Will it let me edit this? No? Nah, it's not letting me fix these. Dang it. Sorry about that. So we see that B is actually 9.12 inches long. Okay, not too bad. Again, it's tough, but 10 is going to be very similar to that. So 10 is going to be very similar to 9. A and B are kind of interchangeable as far as the Pythagorean theorem is concerned. So don't worry too much about if you're missing A or B, you're essentially doing this process. Okay. So let's see here. I might want to zoom in a little bit. I feel like my it's a little bit pixelated when I do the snip. Sorry about that noise. Okay, so let's use inverse trig to find the measure of the angle round to the nearest whole number. And here's a little set of instructions. Again, your calculators are a little bit different than the one I'm using right now, because I can't, I don't have a Texas Instruments calculator emulator. It'd be nice. But anyways, let me give you just a little bit of background here. So we're finding the sine of an angle, x in this case, and we see that the sine of that angle is 4 over 5, which would be 0.8. Don't worry about that. So what I'm actually going to do is I'm actually going to take the inverse sine of both sides. So don't freak out if you're like, whoa, Merrick, what is all this? Because we're going to get somewhere very recognizable in just one moment. So I'm taking the inverse sine, that little negative one, that's the that tells me that we're doing the opposite. We're doing the opposite of sine. Kind of like how sometimes we multiply both sides, or we might divide both sides in algebra. It's the same idea. Just like I said, when I take the sine inverse, it kind of gets rid of that sine. And I'm doing a little bit of magic here, but that x comes down, and really what we're talking about is the measure of angle x, right? So I'm kind of blurring the lines here a little bit when I talk about x here. Really, when we talk about x, we're talking about how many degrees is x. And we still have to evaluate this guy right here, but that's the easiest part, because we barely have to do any thinking. We have to push a few buttons. So let's see. Again, yours is, in my opinion, much better than this. So like I said, 4 over 5 is 0.8. And let's find the inverse sine in this case. So the inverse sine, here it is. And I see that I get 53.13. And I believe I asked you just to round to the nearest whole number. So if I have $53.13, I really have about $53, right? So lucky for you guys, this is all very doable in a calculator, right? This is not necessary. You do not need to write this. I didn't give you space to write this. It is correct and it's useful to know, but it's not the end of the world, right? So on a question like number 13, you wouldn't be using inverse sine, right? You'd be using the inverse tangent, right? Which kind of looks like that. And similarly, of 7 over 6 in your case, right? And that would give you your answer. In this case, you wouldn't be using the inverse sine or the inverse tangent. You'd be using the inverse cosine of 4 over 5 in this case. And that would give you your answer. I'm so stupid. I believe that will give you, well, I won't give it away. I forgot to change these fractions, but it kind of doesn't matter, to be totally honest with you. So let's use inverse trigonometry to find the measure of angle x. So we're doing something very similar. We're actually just starting as if we didn't have this one either. So we actually have to, it's a step before this, the ones that we just saw above. Right, so if that was a piece of cake, then if this was easy and the problems on number 4 through 7 were easy, then you should have no problem with 15 and 16 because it's really just a combination of the two. So let's find, oh, I forgot. Okay, I got to fix this. I'll do the sine of A. So in fact, let me just enter that right now before I forget. Good thing I went through this, huh? Oh, angle X, that's why. Okay, I'll fix that. I'm silly. So it's asking us to find the measure of angle X, and I'm silly, and I have these ones, which are A, B, and C. So I'll fix that. How about this for right now? Don't let me forget. Good thing I went through this, huh? Instead of A, I'll have X. Okay, so angle X is right here. Okay, so if I do, I can actually do anything I want. I can use the inverse sine, I can use the inverse cosine. Let's just use sine, that's kind of the default, right? So I know that the sine of X, the sine of angle X is going to be opposite, right? SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. So let's find our opposite side. In this case, it is 14.63 over our hypotenuse, 17.47. Okay. Now, I don't want you guys freaking out because this looks a lot harder than it is. Again, let me go over to the left a little bit and I can give you guys a little bit of context for what we're doing. It's almost now, we're almost exactly where we were right here, where we started. So again, if the problem above was really easy, then this is also super easy, right? I can find the measure of angle X by simply using the inverse sine of 14.63 and 17.47. Oh, I'm sorry, over 17.47. So if I throw that into my calculator, so I believe I said 14.63 divided by 17.47. And I'll take this and I'll take the inverse sine, and I get 56.87. If I have $56.87, well, I'm pretty close to $57, so I'll stick with that, right? Did I say $57? Yeah, so 57 degrees. So this angle, again, this is the beauty of inverse trigonometry. This angle right here, that's about 50, almost, not exactly 57 degrees, but we can find, it's very convenient, right? Cool. And this is the amount of work that I would expect to see. Again, you could throw this in your, you can put down the decimal if you like. I'll understand what's happening, but again, it's not terribly difficult. This one is hard. So we're trying to find the measure of angle C. We're trying to find the measure of angle C. As you can see, we have the measure of angle A, which is 81.86, and we have the measure of angle B, which is 32.56. That's very simple, right? But we don't have a measure of angle C. How do we find that, right? Well, we can use this wonderful, wonderful law of sines. And in reality, you only need 2 of these. So for example, if you like, you can cross this one out, right? This is the hardest problem by far. So I'll start by just kind of inputting some information. So I know the sine of A, sine of angle A. Well, so I'll start off by writing the sine of angle A, which is 81.86 over little a, right? And we can see little a, it's down here, 59.04. Okay. Well, I know that that's equal to the sine of C. That's what we're looking for, right? We're looking for angle C. And that's supposed to be an uppercase C, believe it or not. Uppercase C. But we're going to keep it uppercase C because we don't know what that is, in fact. Let me color code a little bit. There we go. Big C. The sine of angle C over little c, which is 54.31. This is actually mad easy, especially if I had one of your calculators. This is going to be a little bit of a nightmare for me, just because this calculator is super weird. I normally just use like a Google calculator, but I'm going to be flipping back and forth, so hopefully you don't get dizzy. So I'll do the sine of 81.86 divided by 59.04 first. So the sine of 81.86, let's find the sine of that, and I'm going to divide that by 59.04. And I get this number, very small. So I'll do, just to keep track of what's going on, I'm going to keep this in my calculator. Okay, I'm going to keep this in my calculator, this whole thing. But just to keep track and to keep you on top of what we're doing, I'll just write 0.16, and I'm not even going to round it truly. I'm just going to abbreviate 0.167, just so nobody's getting lost here. All right. So we still have that the sine of angle, so big C, the sine of angle C over, right? Very good. Now, again, like many problems in algebra, we're trying to isolate a variable, which is just in this case, an angle. So just like in any algebra problem, why don't we get rid of this guy? Right? And how would we get rid of that guy? We would multiply both sides by, in our case, 54.31. Sorry, I'm kind of going off the paper, quote unquote, a little bit. So I'm going to multiply both sides by that. And what's going to happen, what that's going to do for us, is that's going to cross both of these numbers out. So on the right-hand side, I'm actually just left with the sine of angle C. Sorry, me and my colors, right? And on the left-hand side, I'm going to have this really, really easy multiplication problem, which I pretty much have set up in my calculator. So I'm just going to take this number, I'm going to multiply by 54.31, 54.31. And I get 0.9106, blah, 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 right? Just do 0.91. Let's just do 0.91, just to have an idea of where we're going. Okay, very good. The last step. Again, if this was easy, you're on easy street now, right? Easy, easy, easy. Why don't I take the inverse sine of both sides? On the right-hand side, when I do that, I'll get rid of that sign right there. Right? So forgive me for not doing the entire algebra rigmarole, and also for kind of deceiving you. That C, really what I'm saying is I'm calling it the measure of angle C, right? So again, a little bit of, how would you say, syntax liberty on my part. But I know that I just need to find, I know that I can get the measure of angle C by simply taking the inverse sine of whatever we have here, right? Which is still waiting for us on our calculator. So I take this number, and I'm just going to take the inverse sine, and I get 65.59. Well, let's just call it 66. So in fact, let me get rid of this because it's not exact. We're at about, what did I say? 66 degrees. Okay. That's our answer. We found the measure of angle C. Yay! Really not too bad, right? So of course, I provide this video because I want to just make sure that I just want to make sure that everybody has access. But as always, please let me know if you have any issues, any questions. You can message me, you can email me. And yeah, I'll get this uploaded and I'll put a QR code on the paper. And I'll get these two problems fixed first. So yeah, just let me know if you got questions, all right? Thanks for watching.